The knowledge of conic sections can be traced back to ancient Greece. Conic sections are among the oldest curves and one of the oldest math subjects studied systematically and thoroughly. The conic seems to have been discovered by Minimus, tutor to Alexander the Great. They were conceived in an attempt to solve the three famous problems of trisecting the angle, duplicating the cube, and squaring the circle. The conics were first defined as the intersection of a right circular cone of varying vertex angle, a plane perpendicular to an element of a cone. An element of a cone is any line that makes up the cone, depending the angle is less than, equal to, or greater than 90 degrees, we get ellipse, parabola, or hyperbola, respectively. Aristeus the Elder, who wrote the still extant 5 books of solid loci connected with the conics, called one of the conic sections the section of an acute angled cone, another the section of a right-angled cone, and the third the section of an obtuse angled cone. Apollonius says in his third book that the locus with respect to 3 or 4 lines had not been completely investigated by Euclid, and in fact neither Apollonius himself nor anyone else could have been added in the list to what was written by Euclid's time. There is no substantiated evidence that he ever wrote an entire work devoted to conic sections, but his knowledge of the subject is obvious in the works we do have. Among the treatises Archimedes published was Quadrature of Parabola, Conoids and Spheroids, Floating Bodies, and Plane Equilibrium. These works share a common thread. They required the extensive use of the properties of parabolas, Archimedes' specialty amongst the conic sections. Apollonius, known as the Great Geometer, consolidated and extended previous results of conics into a monograph Conic Sections, consisting of 8 books with 487 propositions. Book 8 of Conic Sections is lost to us. Apollonius' Conic Sections and Euclid's element may represent the quintessence of Greek mathematics. Apollonius was the first to base the theory of all 3 conics on sections of one circular cone, right or oblique. He is also the one to give the name ellipse, parabola, and hyperbola. While Pappus of Alexandria was a competent mathematician and geometer, we are interested here in his work as a mathematical commentator and historian of mathematics. Residing mainly in Alexandria, Pappus wrote several commentaries on the works of many great mathematicians, especially the books of Archimedes, Euclid, Apollonius, Aristeus, and Minimus. Proclus, who lived during the 5th century AD, was also a notable mathematical historian. Like Pappus, he had access to original documentation of the mathematics of the classical and Hellenistic eras that is no longer available. After the era of these great mathematicians, there was a lull in the growth of conic sections until Pappus. He expanded upon much of what was known, and also proved to be a valuable source to modern math historians trying to learn about Greek methods. With the passing of Pappus, and perhaps Proclus, conics disappeared for over 1,000 years, until being reborn in the 15th and 16th centuries. Though, the work of scientists and mathematicians, like Kepler, who was both conics, evolved from a noble intellectual exercise in ancient Greece to a powerful modeling tool for explaining the physical laws of the universe. Sir Thomas Littleheath was a British civil servant, mathematician, classical scholar, historian of ancient Greek mathematics, translator, and mountaineer. He translated works of Euclid of Alexandria, Apollonius of Perga, Aristarchus of Samos, Archimedes of Syracuse, into English. When Heath's works of Archimedes was published in 1897, the Archimedes palimpsest had not been extensively explored. Its significance was not recognized until 1906, when it was examined by the Danish professor Johann Ludwig Heiberg. Parabola. Parabola is a conic section. The intersection of a right circular conical surface and a plane parallel to a generating straight line of that surface. Circle. Circles are simple shapes of Euclidean geometry, consisting of those points in a plane which are at a constant distance, called the radius, from a fixed point called the center. Ellipse. Ellipse is a locus of points in a plane such the sum of the distances to two fixed points is a constant. The two fixed points are called foci, singular, focus. Hyperbola. Hyperbola is a type of conic section defined as the intersection between a right circular conical surface and a plane which cuts through both halves of the cone.